Hello, this is a continuation of AXI part 4 for the simulation of the AXI stream on the VCS and the iverilog. So I already copied the these four files into the code folder. So I will show you one by one files. We start with the master and then the master test bench. Then we will start with the master to slave streaming test bench. For that we need a AXI stream slave. So we start with the master first. So I will show the content of this code. It is very simple. Just vim code AXI master 1.p. So in this, as if you refer the earlier video, it is same code, and these are the important signalings for the master. I place one packet length as 8. I will gradually increment this packet length counter, and it will send to the data, which is the output of this master, along with the valid and the last signal. So this is a simple code in which master send some data, let's say from 0 to 8, and at the end, at the edge of the data, it will send the one t last signal. Okay, so for the test bench, I just create one clock source and the instantiation of this master. Okay, and I give some passage clocking and one for loop. Let's check what it gives. So for make file, for VCS we need make file. It is the same make file that we seen in VCS EDA tool series. Still, just for the wrap up, I will just show the content of this make file. So we are take the list from the all files from the all files.txt. I will show in what content it will be. This is simple make file where we evoke the VCS, some flags, then file list with -f, then top name. If it is not given, we have to give that name while executing the make command. So after that we will evoke the simulation, that is DVE, and in that we will see the usage of the or signaling of the masters or duck. So we execute make top equals to, our top is the test bench name, master 1 TB. Okay, let's see. Okay, one we need to view that all files.txt. It is simple. We just list all the required files. For this simulation we need only these two files. For the master to slave, then we need these two files again. Okay, back to our simulation. In that you got this test bench along with this duck. Okay, you select all the values from the duck, control 4, it will pop up the waveform window. Okay, just hit F5. Okay, So I remove some unwanted signals from that. So it is very simple. This is a clock, M clock, valid signal, data, and then strobe I kept as always 1. For each byte there will be the one strobe. So for the 32 bits 4 strobe will be there. So this is a T last, and this is we kept this T last below this. So this is a D out data. Else are not required, you can remove that. This is a simple one. Okay, so we go back to the master and slave signaling. So for the master slave we have to just change the name of the top, that is master. Before that we will view what that AXI slave this is the same code that we discussed in part 4. These are the clock reset, these are the T data, keep data valid, T ready, T last. So this ID and the destination user, this can be used for the selection if multiple of slaves are there. So we can use ID and this destination values for the selection of one of the slave. So simple is that. This is a when there is a reset, temp data stream 0, else we are sampling the whatever the input of this slave is coming from the master. Okay, so and we kept the T ready equal to 1 so that continuous streaming can be happen. For the practical purpose we can have this T ready which reflects the process state or steady state of the slave. If it is busy it will goes to 0 so that the master cannot able to send the data continuously. Okay, so for the simulation we just need to change this. For again we need to check the one more code, that is our stage bench code. In the this master to slave streaming signaling, basically we need two components. One is master and second is the slave. We connect the required signal from master to slave and create one clock, virtual clock, and similar for loop for the check for some timing. Okay, so go back to the, so we just need to place the name of the top, make top equals to the name of the top. Okay, so it will create one. So we go back to the master and slave. The required signaling we can take from some masters, clock, T valid, T data, and last, and data. So these are the important signals. We can have select and control 4. It will pop up waveform window. Again from the slave we can have important is T data. T ready is already 1 now. T data, T last and valid. Again control 4. So this much data is required, signal required, so just as you see we can change the radix for it. Decimal is good. So it is very simple that this is the signals from the master's streaming, okay, and this is from the slave. So as we see, the master is sending continuously from 0 to 8 with valid and T last. We can reflect that data on the data bus of the slave. So I hope this is useful for your streaming AXI streaming implementation. Okay, we will back to the iverilog simulation setup. Now for iverilog, I just make a copy of these codes and some changes in the test benches. Okay, for overview, this is a master, same code is there, okay, and in test bench of the master I just make some initialization initial block. Earlier it was always, I just make it happen, and the one additional of the $finish, so that it will dump the, and this is for the .wav file, so that we get all the signals in this file. So, and similarly this is for the slave stream device, same thing is there, okay, and I just add similar thing in the test bench of the master to slave streaming for the .wav file, because for the iverilog we need to have this kind of setup for the WAV files. So I just remove the always block and make it happen as the initial block. At the end I just put the $finish. So for the simulation I have my own wrap up AXI for the iverilog and the GTK. So my GTK is open while I am recording this, but it will not show the any waveform. But anyway, after the recording I will, for the master I have to put the master duct and the test bench file open, then compile and simulate. Okay, it will open the GTK. I will select the files from the duct. The required files required signal is clock, then data, last, and the valid. These are the important signals. So it will not show in this GTK while recording. I will put here in this after the edit of this video. Okay, back to the master to slave files. We need a master streaming. These three are required. Again it will compile and generate the waveforms. In that also we need some master and slave signals for the data, then last, valid for the master and slave. So after while editing this video I will put in this area as a waveform. You can have that look. Okay, thank you. Please subscribe my channel if this finds too useful to you, and make a comment if anything or any doubt you have, or for what next design you want to be like that. Thank you.